Hello, this is Jessica Du Bois, and I'm presenting my modeling equations with graphs, a technology-based approach for my instructional design project. One of the problems at our high school right now is a very low passing rate on the CORE Algebra 1 exam. Through some subtopic tests and other needs assessments, we've indicated that there's a need for increased rigor, student participation, and some differentiated learning strategies. From this, I've developed a hybrid of online and traditional instruction. The high school is also currently one-to-one with iPads, and they use a student management system similar to Blackboard called My Big Campus. These online modules will allow for a more student-centered approach with a graphing component through the use of technology. I've chosen to use the layer of necessity model. I think that this is the most appropriate model. The layer of necessity model is self-contained, and each layer is independent of the other layers. Even at the most simplest layer, there is 5 basic components, and time and resources that are available are crucial variables to choosing the complexity of the model. So the more the increase in time and resources, the more in depth it would become in the model. The 5 basic components, even in layer 1, are situational assessment, goal and task analysis, instructional strategy development, materials development, and evaluation and revision. As you can see, even a more complex model just has an increase of time and resources, and the design process continues to improve itself as you recycle back through to a more in-depth model. Some of the characteristics of the learners in this class would be, the majority of the students would be sophomores. They have taken Algebra 1 and received credit and passed the course, but did not pass the CORE 40 exam. These students typically would not attend a traditional 4-year college after graduation. If students do not pass the CORE 40 exam by their senior year in graduation, they will only receive a certificate of completion and will not receive a CORE 40 diploma that is required by most colleges. The 3 instructional goals for this project are students will be able to identify the slope and understand its application, 90% mastery. Students will also be able to manipulate a standard form equation and use the technology to graph it and identify its slope, also with 90% mastery. And then to sum it up, students will complete the learning task within the module in the given time constraints with 90% accuracy. Some of the instructional strategies in this module will be every student will receive large group instruction. They'll then proceed at an individualized pace to complete the instructional task within the module. These tasks would be a variety of things, including a Khan Academy videos, graphing equations on an iPad, graphing application. Small group instruction could be one-to-one instruction and some lab activities. Students will also at some point have the ability to select activities of their choice for their task completions instead of be given tasks. Quick checks are in place to identify areas of remediation. Students cannot go past these areas until they have remediated to mastery. Enrichment activities are also available for students who show mastery. Now, within this model, as you can see, with the situation, starting with situational assessment, it goes through, and then there is a quick check assessment. At this quick check assessment point, feedback is provided. If the student does have mastery, then they go to enrichment and then ultimately to a topic assessment. If students do not have mastery at the first quick check, then they will go to small group instruction with a teacher or a co-teacher, identify additional remediation needed, and have additional tasks. If that is proven to mastery, then they will go to enrichment and the assessment. If not, they will go down to individualized one-to-one instruction and some more skills remediation. To evaluate this design component, student will complete surveys. Their learner analytics will be compiled, which will include the grade on the module, the activity grades, time of completion, and the topic test grade. After CORE 40 data comes back, the data on the linear equations will be examined. Those students who were successful will be interviewed by the administration for additional feedback upon the hybrid instruction course. Hopefully that will allow the teacher to improve instruction through both of these methods. The outcome of this hybrid instructional design is that students will complete a topic test with 75% mastery and will ultimately master the subsection of the linear equations, graphs, and the CORE 40 exam. This will increase rigor and prepare our students for college readiness. Thank you.